Hey everyone, welcome to the workshop. Thanks a lot for having me and joining today. I'm Martin. I'm DevRel, a developer relations engineer at Ava Labs, and today I will talk about Avalanche and how we achieve scalability, independence, and compliance. Okay, so as we see blockchains or generally distributed ledger technologies, we see it as in three generations, right? Like, so the first generation of blockchains very early on, not only Bitcoin and Zcash, actually there were a few before that, were single chain, single asset blockchains, right? Like, so you have a single chain and one asset. For example, with Bitcoin, you have the Bitcoin chain and the Bitcoin asset. And then eventually Ethereum came around with this new innovation of smart contracts, which opened up a world of having not only the native asset, right, like ETH, but also many other assets, right? We know today on Ethereum there are stablecoins, there are ERC20 tokens, NFTs, all kinds of things. So this was a real innovation over Bitcoin. The next generation we see as multiple chains, multiple assets, right? So we not only have a single chain that fits all, but actually a network of interoperable chains, and each of these chains can have a number of assets. And in this talk, I will explain a little bit why we see this is an improvement, and it's important in enabling new use cases. So what that means is, right, like we're moving from a single blockchain with a fixed validator set to now a heterogeneous network of blockchains with various validator sets. So the question is why, right? Like, why would we do this? You could ask, like, let's introduce additional complexity. Now we have to bridge between these chains. I will explain real quick why. So there are three main reasons. The first one is independence. The second one is scalability. And the third one is compliance. And this is especially important in enterprise use cases, especially the financial world, if traditional finance financial institutions and governments, we want to have them move on chain, right? So let's start with scalability. So scalability is the idea of having, kind of like a scalable blockchain with a high throughput. So blockchain performance can be a little bit hard to measure, right? Like, we do know like two major metrics, performance metrics, and it's important to know that these are performance metrics. So I want you to think of this analogy of a highway, right? So we have a highway with every transaction is a car, and the car enters the highway when you click send on your wallet, right? Like, so you're sending a transaction, and it exits the highway when the transaction is confirmed on chain, so it can't roll back, it's finalized. Right, so this analogy will help us a little bit to think about how blockchain works, and it's important. This is just a performance. Blockchains have different metrics, right? Like decentralization, all kinds of things. But this little mental model will help us, right? So when you think about blockchains, I want you to think of a highway, and the two metrics we have here are one, throughput, and time to finality. So time to finality is the time it takes between the car enters a highway until it exits the highway. So you click send in your wallet, and then eventually you see the pop-up, transaction finalized, you can see it in the Explorer. And the other metric is throughput. And throughput is the number of lanes of the highway, right? So how many transactions can enter a highway at a time? And it's very important to understand that these metrics are not necessarily related, right? Like, you can have a very, very wide highway where hundreds of cars can enter per second, but that says nothing about how long it's going to take the cars to get from the start to the destination, right? So, and that's really important to understand, that these are not related. And it can get a little bit tricky, because when we talk about throughput, we talk about transactions per second, right? And some people think, oh, it's 10% transactions per second. That means my transactions will take a tenth of a second. But that is actually not true. 10 transactions per second means 10 highways can 10 cars can enter the highway per second, but it won't say anything about how long these highway cars are going to spend on that highway, right? So it's very so what kind of like highway do we want to build, right? If we want to go, for example, from Munich to Berlin, we want to build a highway that has many lanes and that goes the most direct route. What we want to avoid is a highway that, you know, takes a detour through Paris, is single lane, so it easily, you know, is congested, and yeah, takes unnecessary detours, right? Like, so what we want to do is high throughput highways with short time to finality. And if we think about like blockchain systems we know today, right? Like Bitcoin, for example, has a finality of 60 minutes. So you enter the highway, it takes 60 minutes to get where you want to get to finality. And it only has a single lane, right? 7 transactions per second. So not a lot of cars can enter that highway at one point. Ethereum is already much better, right? We have a higher throughput, but still transactions take around 15 minutes. So not really practical for many applications, and definitely not practical to get yeah, a lot of people and a lot of processes on chain that aren't there today. So if you look at Avalanche, Avalanche has a decent number of highways, around 2,000 transactions per second. But the most important thing is the finality is under a second. So you enter a highway and you get you to your destination in under a second, which takes 60 minutes on Bitcoin. Right, so this enables a lot of new use cases that are just not feasible, right? Like many things in finance you can't do if you have a finality of 60 minutes or even 15 minutes. Like you really need this sub-second finality. So this sounds good and all, but now we have to think about like how can we scale for the masses, right? And our highway is good, but it doesn't really won't allow like 2,000 transactions per second is nothing really. So hold on, the slides are taking off without me. So what I want to show you here is we have the validators of the Avalanche network, right? So as every other blockchain network, they are connected to each other and they are validating one chain. And first, they are validating the primary network. So if you interact with Avalanche with a C chain, for example, that's part of the primary network. There are 2 other chains in the primary network. So we have one chain, one highway, right? That is decently wide already, but won't be able to accommodate all business processes of the world. So then we add now another highway by having a subset of the validators, right? Like, so not all the validators, just a few of them, validate this additional highway, right? Like this additional blockchain. And it is completely independent of the primary network. So it adds another 2,000 transactions per second to the Avalanche network. And we can keep doing this, right? Like with another highway and another highway. And there might even be overlaps between the two. So you can see here, we can build a massive throughput of all these highways that are running in parallel that are completely independent, right? We can go one further. So you can see here, right, like there's no limit to the number of highways we can have. And if you take these highways now, all together, they're running in parallel, they have a massive combined throughput, but they don't have to sacrifice any of the short time to finality to make that work, right? So that's a general idea of Avalanche, of the scaling approach in Avalanche. It's quite simple, right? We don't introduce anything new, zero knowledge, or any other, you know, like new technologies. It's a rather simple approach. But the art here is really how to make these subnets and these highways interoperable. But there are a few other benefits over this with this approach. And one namely is independence. So what does that mean, right? So all these highways are independent. So one important topic here is fee isolation. So if you use the Ethereum chain, for example, or any other public blockchain, you will see that there are massive spikes in fees, right? Like the fees of the chain may, you know, triple, 10x, even sometimes 100x, because there's an NFT drop going on. So think that you are a startup or an institution and you're offering some service on chain, right? These fee spikes will eat into your profits because a user is ready to pay a certain sum for your service. The user doesn't care if he pays gas or pays your fees to your protocol fees. They just know I'm taking action X and I'm paying amount Y for it. And it doesn't really matter to them where the money goes. So these fee spikes can really eat away your profits because yeah, it's not calculatable, and you can't really. These fee spikes are also caused by something you have nothing to do with and you don't profit from, right? So what are fees, right? Like if you think about what are fees are ways to disincentivize people to use your chain, right? Like, so we have limited block space, and What happens if a chain gets full, right? The fees rise, so it gets more expensive, so less people use the chain, right? Like we don't want the chain to get stuck, to get overloaded. So when many people use the chain, so on a public chain, you share one highway with every car, with all the cars. But on Avalanche, each of these chains is independent. So the fees of a single chain may rise when it gets busy, but all the other subnets are completely independent. So if you're an enterprise and you deploy on Ethereum and there's an NFT drop, you are directly affected. If you deploy on an Avalanche subnet and there's an NFT drop happening on another chain, you don't have to worry about it. It doesn't affect you at all, right? So this is the first part of the independence fee isolation. But another thing is also customizability, right? So let's think about, we have a highway, people are traveling by car. But now you have a special use case where people actually don't want to travel by car. They want to travel by boat or by train. While it's theoretically possible to dig out a lane in your highway of the Ethereum network and fill it with water, it is technically very, very hard to do. And also, it requires consensus of the entire Ethereum network. So let's say, you're a protocol and you want to use some new ZK technology. To get that into the Ethereum client, it's a lengthy process of proposing an EIP, building consensus in the community that this is a good idea, and then merging it into the Ethereum client. This can take sometimes years, right? So this can limit your ability to customize, to build like new products if you require like something that's just not available or not economical on the Ethereum network. If you have your own chain, you can do and specialize a lot of it with it to meet your requirements, and that helps a lot. So what does that mean? Let's dig a little bit deeper, right? If we look at the Ethereum stack, there are different layers, right? We have the consensus layer, we have the execution layer, the EVM, and then we have the smart contract layer. So if we compare it with the Avalanche stack, it's a little bit different in Avalanche. So all the chains have a shared consensus layer. They all run on Avalanche consensus. But every chain have their own execution environment. And these may be EVMs, right? But they also may be slightly customized version of the EVM, right? So maybe the gas price is different. The gas native token is different. Maybe the gas configurations is different. Maybe the EVM has been customized to include new precompiles that enable some ZK account abstraction or whatever, right? And then we have the smart contract layer. But this is only the first step of customizability. Actually, the Avalanche network itself is completely virtual machine agnostic. So there might be many EVM chains, but right now we have one team, for example, building a Move VM. So Move is the programming languages blockchains like Aptos and Sui use. And they are building a virtual machine in the Avalanche network where people can deploy Move programs. We also have a team building a WASM VM where people can write programs in Rust, compile them down to WASM, and launch them on the Avalanche network. So you can really see here there's a wide variety. There are many SDKs to build specialized virtual machines that cater much, much better and are much, much more efficient than maybe the EVM and enable completely new use cases. This is obviously not suitable for the average DeFi application, but if you are, like a high throughput financial application or something like DYDX that want to move to the next level of efficiency, right, you might want to consider building your own virtual machine and programming the business logic directly into the virtual machine. Okay, so the last topic I want to talk about is compliance, right? So we want to see many institutions move on chain. And why do we want to do that? Because if institutions move on chain, we increase accountability, we increase transparency, and we make it much more secure what they're doing, right? So to do that, many chains will need to start in a permission setup, right? Like because of regulatory issues, because of just their business processes. So Avalanche gives the optional possibility to permission a chain. That doesn't mean that every chain on the Avalanche network needs to be permissioned. It's completely optional. And we believe by giving this option to institutions, we can move more processes on-chain that are happening today in completely closed-off data centers. So it's an improvement over the current situation. Obviously, it's not the perfect situation where everything is permissionless and public, but it's definitely better than what we have today. So the permissioning can happen on the validator level, the smart contract deployer level, and on the user level. So let's look at what that means, right? So let's say you are a company in the European Union and you want to bring health data on chain. Because of European privacy laws, you are not able to store them anywhere outside of the European Union. So you can launch your enterprise blockchain and requiring the validators to be all part of the European Union. Or another use case may be where the validators are all situated in North America, right? Like, so this enables compliance for companies. And the other one is permissioning, right? So you can think of as if we permission our highway and we control which cars can enter it. And we can do this for two things. So the first one is smart contract deployers. So we can decide who can deploy smart contracts on the chain. So this can also be administered by a DAO, right? Like, it doesn't have to be a single entity, but you can configure your chain in a way that not everyone can deploy smart contracts. So if you're, for example, a financial institution or a consortium of many financial institutions that want to interact on a chain, but you want to reduce the regulatory risk that someone comes up with the idea to deploy Tornado Cash on your institutional chain, this will be very, very helpful for you, because you can, cut it off right there and only allow maybe this trusted set of institutions that are doing stablecoin swaps or whatever on the chain to deploy smart contracts. And the other alternative is user-based, right? So you can, for example, permission the chain only for KYC user, right? And this may open up. This will still be better than a traditional exchange, right, where everything happens in a traditional Web2 data center. It's much more secure. It's much more transparent. But you can still keep, compliant with local laws and do that. All right. So this was, and then the next question is kind of like, how do we do this? And you can now think like, okay, like, how can I actually build my own blockchain? And actually, it's very easy. So I encourage you all after this talk, check out Ava Cloud. It's for enterprises, our portal where you can easily spin up a blockchain, and you will see in a few clicks, the process is so smooth. You can spin up a DevNet, meaning your own Avalanche blockchain. It's all EVM blockchains here. You can connect to it with your wallet. You can issue transactions and see it's actually a fully fledged blockchain. So definitely check out Ava Cloud to see more how easy it is to build a blockchain and create it on Avalanche. And if you want to learn more about this, right, like I covered a lot of stuff now in a very short time, definitely check out Avalanche Academy. There are different courses. Avalanche Fundamentals is what we just talked about in a little bit more detail. But then you will learn more about the subnet architecture, its possibilities, but also about how we can integrate these blockchains with each other to be interoperable without introducing any additional trust assumptions. You can also learn how to customize your EVM to meet your needs and everything. So lots of interesting courses there. It's all free. You get a certificate at the end. And there's also in the university chat. So if you're looking for opportunities in the Avalanche ecosystem, I definitely recommend joining Avalanche Academy, connecting with other students, and also our developer team there. And this is it from my side. Just one thing. If you are building a startup and considering building it on Avalanche, definitely check out Codebase. Codebase is our accelerator program. So the first cohort is kicking off right now in March. So the applications are already closed, but we will have a second cohort. We will have 2 a year. So the next one is coming in September, like fall, September, October. And when you join the Codebase cohort and are accepted, you get a $50,000 stipend. So you don't have to give up any equity for this. You just get $50,000 for the 10-week program to cover living costs of the team and everything. And then you go through a 10-week program with training with Avalanche developer relations engineers and many industry experts. And then at the end of the 10 weeks, there will be a demo day with many VCs where you can hopefully raise some seed funding for your startup. So if you're interested in that, definitely check out Codebase by Avalanche. As I said, 2 patches per year, around 15 companies, and there's a massive prize pool at the end. And as I said, the application is closed for March, but we will open it up, I think mid-year, like around June, July. And so if you have any questions, reach out to me. Feel free to connect with me on Twitter and ask any questions. Otherwise, it was a pleasure talking. I don't know if we have the opportunity to take any questions, but happy to do so.